Hello everyone. This session I will be discussing straight lines in three-dimensional space. Already in the previous sessions I have explained the concept of direction ratio, direction cosines. We have solved many examples. So I'll assume that all of you are familiar with direction ratios, direction cosines of a line or a vector. See, we are doing straight line in three-dimensional space. We are studying it with the help of vector. Is there any difference between the equation of line you got in 2D and 3D here? Obviously, because 2D, the equation of line was determined by two variables, x and y. Here, we can study in terms of three variables because the point in space has three coordinates, x, y and z. Apart from this, there is no difference because in two-dimensional geometry, a straight line is determined by knowing a point on it or 2 points on it. If you know 1 point and slope of the line, then it is done. Here, we'll compare those direction cosines plays the same rule as that of the slope of line. I'm not saying that meaning is equal, but they will help you to get the equation of line. If you know direction cosines of a line or direction ratios and the point on it, then we can get the equation of line. And that can be referred as 1 point form of a line. In two dimension, you have got a line passing through 2 points. In fact, only 2 points required in 3D also to get the equation of line. If you know 2 points on a line, then equation of line can be determined. Now, I'll start by stating the locus of a point which will be considered as a straight line if its direction remains the same in three-dimensional space. At whatever point it goes or in any time, direction will remain the same. So locus of a point which moves in such a way that its direction in three-dimensional space is fixed, then it is said to be a straight line. Okay? So we can find equation of a line by knowing the direction of the line, which will be characterized by a vector in that direction and a point on it. So suppose there is a line here in 3D geometry which is directed along a given vector B, say, and we know a point on it whose position vector is A, then we will find the equation of the line. And I am telling you in advance that if you know 2 points, then if you know 2 points on the line, say A and B, then also we can find the equation of the line, because when 2 points are known, we know the direction of the vector in the direction of the line. So either you need a vector and a point on the line or 2 points on the line to get the equation of a line in 3D. And see the advantage of learning vector properly to study straight lines in 3D. So let us find the first form of equation of line, which is vector form. So I'll name this one as equation of line in 1 point form. I need to state we'll always find symmetry with that 2D. We know the slope and the point, that is referred as 1 point form. Here we know direction ratio and the point on the line, then we can find equation of the line. So to find the equation of line, along the direction of the vector B, and a point on the line is A, whose position vector is A. To get the equation of line, we need a variable point, because the variable point is moving in such a way that its direction, the way it moves, will be along the direction of this vector. So take an arbitrary point on the line which is R. R means in Cartesian equivalent it will be x, y, z. So let PR be an arbitrary point on the line. Okay. Now A is given point, P is a point, arbitrary point on the line. So AP has the direction which is same as that of vector V. So can't I say that AP and B vector are parallel vectors? Understand? Since AP is parallel with the vector B, therefore you can write AP equal to some scalar into B, where T is a scalar. So R minus A going to be T into B. R equal to A plus TB. Okay. This is the equation of line on which a point A is known and R is an arbitrary point and T is a scalar over there. Okay. So this form is known as vector form. This is vector form of a line, and that is to in one point form. Now we will try to write the scalar form. How to write the scalar form here? Scalar form we need to convert. Okay. In scalar form, we are going to find the equation of line which passes through the point x1, y1, z1 and directed along a vector whose direction ratios are A, B and C. So state first, to find the equation of line passing through the point x1, y1, z1 and parallel to the vector whose direction ratios are A, B and C. Okay, or the line itself will be directed in such a way that direction ratios of the line, we have explained direction ratios of vector or a line. In the previous episodes, if you see, I have always explained that it is direction ratio of a vector or a line when you have started 3 dimension. So to get the equation, you take an arbitrary point on it which is x, y, z. Okay, this is not x1, it is x, y and z. Arbitrary point on the line. So let P, x, y, z be an arbitrary point on the line. Now, what is the direction ratio of AP? direction ratios of AP are x minus x1, y minus y1, z minus z1. But you have stated that direction ratios are A, B and C. So these two quantities equal or proportional, that you have to decide. Equal we cannot assume, they must be proportional because line has direction ratios, you have stated A, B, C. But direction ratio you have got here, so they must be proportional. Now x minus x1 is proportional to A, isn't it? So you can write x minus x1 equal to t into A. Number 1, y minus y1 t into B, and this is t into C. Okay, so what we get from here? X minus x1 by A equal to t, which is nothing but y minus y1 by B, nothing but z minus z1 by C. Okay, so we get required, because all are equal to t, so required equation of line in scalar form going to be x minus x1 by A, y minus y1 by B, z minus z1 by C, and vector form are equal to A plus 3B. For the same line, we get this one as the vector form and this one is the scalar form. Okay, and they are interchangeable. We can get scalar form from the vector and vector from the scalar. Now just consider one thing, that let the equation of line given as, I just explain one conversion here. Let the line in vector form be r equal to say 2i 4k plus t into I plus 2j minus 3k. Because that A is a vector, we have taken A here, B is another vector, the direction of the line we have taken here. Your problem is to convert this line in scalar form. How to convert this one into scalar form? See, this point is known here and that point we have taken as x1, y1, z1. So in this problem, we can, if we compare with this line, then 2i minus j plus 4k going to play the role of the known point, that is x1i y1j plus z1k, and I plus 2j minus k is in place of ai bj ck, because the direction ratio is also, the direction vector, in that direction a vector b is there, that has direction ratios abc. So that vector ai plus bj plus ck will be compared to what? It will be compared with I plus 2j minus 3k. So what is x1, y1, z1 over there in vector form? That is actually 2 minus 1, 4, written in the form of vector only. And what is ABC over there? The direction ratios ABC. These three or the triplet ABC can be compared with 1, 2, minus 3. So now you can write easily the scalar form. If the vector form given this way, the required scalar form going to be what? Required scalar form will be x minus 2, y plus 1, z minus 4, that divided by ABC. What are ABC over there? That is 1, 2, minus 3. So the line given in vector form, we can easily write the scalar form over there. Just by remembering the concept that the known point is given here, that 2 minus 1 4, and the line directed along 1 2 minus 3. Now if you are given a line in, I am just taking one example, scalar to vector, how to get. Better we deal with the problem. Let the line given, equation of line be x plus 1 by 3, y minus 2 by 4, and z plus 3 by 5. How to write this one in vector form? In vector form, we want to write it as r equal to a plus t into b. What is t? What is b? T is a scalar. B is the direction of the line. So here a will be what? This equation is rewrite in the form x minus what? X minus minus 1. Because scalar form always you write this way, x minus minus 1 by 3, y minus 2 by 4, and z minus minus 3 by 5. So the point on the line, many points are there, but one point is known. A point on the line is minus 1, 2, minus 3. But a point on the line we need to get in the form of a, which is a vector. So how do I write a? A will be minus I, 2j, minus 3k. How do I write b vector? It is directed along 3, 4, 5. So b going to be along 3i, 4j, 5k. Clear? So now let us write the equation of line in vector form. That is r equal to a plus 3b minus I plus 2j minus 3k plus t into 2i plus 4j plus 5k. Okay? So this I have taken one numerical example. Suppose you are given a line in terms of those symbols. That line given, say, x minus x1 by a, y minus y1 by b. Just by seeing it, we can write the vector form is if scalar form is this, the vector form is what? Vector form is going to be r equal to a. A is a known point, that is x1i, y1j, z1k plus t into ai plus bj, sorry, ai, not a vector, ai vector, ai bj plus ck. Okay? So now these two forms are interchangeable. Just by seeing it, you need not remember any technique over there. Just given x1 and z1 on the scalar form, it comes here and ABC goes there. Similarly, vector to scalar, how to write? This is x1, y1, z1, you put it there. And these are ABC, those coefficients, you put it there. Just by seeing it, you can write scalar to vector and vector to scalar form. Okay? Now we are going to write 2-point form. What is that? 2-point form means the equation of line passing through two given points. That we write 2-point form. That is equation of a line passing through two given points. Say I am taking in vector form first, B. Okay? This is 2-point form. 2-point form is what then? Equation of a line. Equation of a line passing through two given points. Those given points are A and B. Okay? These are two known points on the line A, B. We have to write the equation of the line. I told you when 2 points are known, in that direction a vector is also known. So if this is the line, it will be directed in what direction? Along AB. So the line directed along AB. And a point on it is known. Okay? So we can write the equation of line just by using previous concept. So since the line is directed along AB. AB what? Position vector of B minus position vector of A. Since the line directed along B minus A point on the line which we need for 1-point form, a point on the line, you can take any one of them, A or B. So line will be what? R equal to A, the point known, A plus T into B minus A. No other vector is required, only 2 points are enough. In straight line in 2D what you have seen, there are also 2-point form. If 2 points on a line known there, you got slope of the line. Here you got direction ratios, if required, direction cosines of the line also. So now equation of line in vector form you got. In scalar form how to write? I'm just writing it here. Imagine that this point is x1, y1, z1, a known point, and this is x2, y2, z2. Then what is AB vector? That B minus A, how to write? I'm just getting it from here. B minus A, the line directed in what direction? Along AB vector. Scalar form I'm going to do. The line is directed along AB. AB is what? That is position vector of B minus position vector of E. Okay? So this is going to be x2 minus x1I, y2 minus y1j, z2 minus z1k. And we are taking that A as x1, y1, z1. So that scalar form, that vector form, more elaborately if you want to write, it is going to be R equal to A. A means what? x1I, y1j, z1k. And T into AB vector, that B minus A is what? That is position vector of B minus position vector of A, which is AB. So T into x2 minus x1I, y2 minus y1j, and z2 minus z1k. Okay? So you know a point on the line, you know the direction of the line. I told you in the previous form that vector form known means a point on it is known, x1 and z1, and the line directed along this vector. So scalar form going to be what? You can write its scalar form. Required scalar form will be a point is this x minus x1 y minus y1, and it is directed along y2 minus y1. Here it is. This is 2-point form. Okay? So this way you can get both scalar and vector form of a line which is in 2-point form. 2 points are known on it, then you have to write the equation of the line. Okay? Now, let us solve one simple problem here, and then we'll find intersection of two lines, etc. So let us write the equation of line, in scalar and vector form, which passes through 2 points a 2 1 minus 3 and b 4 3 1. Okay? How to write? So this is just a simple example, direct application of the concept we have learned. 2 points are given. Let it be x1, y1, z1, and this one x2, y2, z2. So scalar form going to be what? X minus 2, y minus 1, this divided by x2 minus x1, that is 4 minus 2, 3 minus 1, and then 1 plus 3. X minus 2 equal to y minus 1, and that is z plus 3 by 2. Okay? This is the equation of line which passes through two given points, and this we got in scalar form. Vector form, how to write? We have to write in vector form. In vector form, it is going to be r equal to a. A is what? This known point. You take this one or this one. It doesn't matter. 2i plus j minus 3k plus t into 1 into I, 1 into j, 2 into k. Okay? So this is in vector form. Equation of line in scalar and vector form which passes through these 2 points is vector form is here and scalar form is here, and this one is the vector form. Okay? Now I will be discussing collinearity of 3 points. Under what condition these 3 points x1, y1, z1, b, x2, y2, z2 are collinear? Line can pass through 2 points. those 2 points be A and B. On it, C may or may not lie. How to verify? What we'll do here first, let me explain with the help of the scalar form first. That we first write, step 1 will be write the equation of line through 2 points A, x1, y1, z1 and B, x2, y2, z2. What is that? You know that line is x minus x1 by x2 minus x1, y minus y1 by y2 minus y1 and z minus z1 by z2 minus z1. This is the line which passes through 2 given points x1 and z1 and x2, y2, z2. In 3D what you have done? In 2D what you have done? Just put the third point. If the equation through first 2 given points satisfied by it, then it is done. If it is not, then they won't be collinear. So here you just need to put C over there. Now for x, y, z, when replaced by x3, y3, z3, what condition do I get? That x3 minus x1 by x2 minus x1, y3 minus y1 by y2 minus y1, z3 minus z1, this one must hold. This one must hold. These 3 ratios must be equal. This one must hold for collinearity of 3 points x1 and z1, x2, y2, z2 and x3, y. This is actually our step 2. So what you have done? Write the equation of line passing through 2 given points. If the third point you put in place of x, y, z over there and 3 ratios are equal, then you can say that the 3 points are collinear. Let me take one example here. Check whether these 3 points are collinear or not. A 3, 4, 7, B 2, 3, 6 and C 5, 7, 13. See, vectorially you can check, you have already done that AB vector and BC vector, they are parallel or collinear, then one vector will be the scalar multiple of the other. But I want to show you with the help of the scalar form of equation of line in 3D. How to? We just take it this manner. We write the steps I told you. First write the equation of line here. So equation of line passing through A and B is what? X minus 3 by x2 minus x1, y minus 4 by z minus 7 by 6 minus 7. Okay. So we found the equation of line passing through 2 given points A and B. X minus 3 by 2 minus 3, you can do 3 minus 2, 4 minus 3, 7 minus 6. It's up to you, but I have taken opposite. So what have I got? X minus 3 by minus 1, y minus 4 by minus 1, oh my god, all are minus 1, whatever, multiply by plus 1 here. Now, this ratio will be satisfied by 5, 7 or 13 or not. We put, you replace x, y, z by 5, 7, 13. This is going to be what? 5 minus 3. 7 minus 4. Y is 7 and Z is 13. So you are getting 2 equal to 3 equal to 6. No, not possible. This is not equal, never equal. So points are, therefore, given points are not collinear. It's okay. 3 given points are not collinear because the ratio not satisfied. So write equation of line passing through any 2 given points. Check whether third one satisfying it or not. Then it is done. If it is not satisfied, they are not collinear. If it is, they must be collinear. Now I am going to tell you some important points or some important observations what we have just done in straight lines in 3D. This we are writing as important notes on equation of line in 3D what we have studied so far. See, we got the vector form r equal to a plus tb and the scalar form x minus x1 by this a and this a are not same. Please remember this. These are direction ratios of the line. Either vector form or scalar form. We can convert scalar to vector, vector to scalar. All these things we know. Now, when you are saying, suppose we continue with the scalar form. A, B, C are what? Direction ratios. A, B, C are direction ratios. If I want to write a line parallel to this line, how can I write? Which quantity is going to be changed? Either in vector form or scalar form. So first observation we write line parallel to a given line. Which quantity is going to be changed? Line given is either in this form, vector form, or in scalar form. So you will be changing the point on the line, that is A. B will remain the same. So in vector form, if you write line parallel to r equal to a plus tb can be taken as r equal to, point will differ. There is another point. In place of a, there may be a dashed. But this thing you cannot change. You write AC into B. AC is a different scalar, doesn't matter. That scalar, the line actually in scalar form independent of the scalar. Okay? So that A dot is a point on the second line. That first line, a point on it is A, and here the point on this line is A dash, which is A dash. But both are directed along the same vector B. Scalarly, how to write a line parallel to this line? A line parallel to this one in scalar form, a line parallel to it can be written as, which part will remain the same? Same concept. Vector, scalar, whatever you think, that ABC will remain the same. Can be written as x minus x0 by A, y minus y0 by B, and z minus z0 by C. What are those x0, y0, z0? x0, y0, z0 are the points on the second line. Point on the second line. Direction it should remain the same. Only a point will determine the other line which is parallel to this line. So I just take one simple example here. That line parallel to, if we want to write equation of line parallel to x plus 1 by 3, y minus 2 by minus 5, z plus 3 by minus 4, and passing through a point, say minus 3, 1, 7. So line parallel to this and passing through this. How to write? Point on the line known and direction issues are there. 3 minus 5 minus 4. So required equation going to be what? X minus minus 3 by 3. Y minus 1 by minus 5. Z minus 7 by minus 4. You write Z minus 7 by minus 4. So simple. That is x plus 3 by 3, y minus 1 by minus 5, z minus 7 by 4. This is one important observation we made here just now. That is line parallel to a given line, how to write. Hope you have understood. Now the second important point, the second observation. See, the line, suppose given in scalar form, x minus x1 by a, z minus z1 by c. This is scalar form. Now, direction issues of lines are, DRs are a, b, c. What are the DCs of the line? DCs of the line are A equal to A by, AM equal to B by, and C by under root sigma A square. These are element in relation cosines of the line. Now, suppose this scalar form I am dividing by under root sigma A square, y minus 1 b by sigma A square, dividing all issues by sigma A square. Now, we have already studied this is a direction cosine L, M, and this is N. So, after dividing we can write x minus x1 by L, y minus y1 by M, z minus z1 by N. Now, what I want to say, line you can express either in this form or in this form. But how do you understand whether it is given in terms of direction ratio or direction cosine? Very simple. We'll just check whether sum of the squares of these three quantities are given to be 1 or not. Sum of the squares. If a square plus b square plus c square equal to 1, those are to be considered as direction cosines. If not 1, they are just direction ratios. So, before you solve any problem based on it, keep this in your mind. The line can be given in terms of direction ratio as well as direction cosines. There is no problem in writing any one of the two given forms. Now, the third important point, third important observation, I want to tell you the equation of line, what you got here, r equal to a plus tb, or scalarly x minus x1 by a, y minus y1 by b, z minus z1 by c. These are known as the symmetrical form of a line. If you write in this form or this form, this is called symmetrical form. of the equation of line. Why I want to make you observation over there? Because when you are dealing problem with 3D, the equation of line, the coefficient of x, y, z, if it is given, all are equal to one line given exclusively in this form, then we will say that it is symmetrical. If it is not, then before you solve the problem, I'll suggest you to convert into symmetrical form. If coefficient of x, y, z are not given 1, you must make it 1 by dividing and then proceed. Okay, let me take one example. A line given as, I have given two problems here, x equal to by plus c, z equal to ay plus d, all given in this form. Write those lines in symmetrical form. They are not given in symmetrical form. How to express in symmetrical form? We just use the common concept of ratios only. How to? Just I am answering number 1. Say. X equal to by plus c. So, x minus c equal to by. Okay. So, x minus c by b equal to y by 1. Isn't it? And then it is given z equal to ay plus d. Therefore, z minus d equal to ay or z minus d, that I want to make y1, then comparison will be easier. Z minus d by a equal to y by 1. Got it? Now, once we got x minus c by b, y by 1, and then z minus d by a equal to, so x minus c by b and z minus d by a, both are comparable, you just compare. So, therefore, we get x minus c by b, y by 1, z minus d by a. This is expressed in symmetrical form. Now, somebody asked you to write a point on the line. How do you write it? So, answer is very clear. A point on the line is what? You can write y minus 0, that is c, 0 and d. And direction ratios of the points are what? The direction ratios of the line, layers of the line are B1 and D. Hope you have understood. So just compare, just make two variables comparable with the other one. Then it is done. So it is simple concept of ratio only I have used to convert into the symmetrical form. If you want to write the vector form of it, how do you write? A point on it known and direction ratios also known. So vector form will be what? The vector form will be R equal to A plus TB. Ci 0j dk plus T into Bi plus j plus dk. Hope you have understood. Now let us go for this one. Not like previous one. Here, this here equal given. How to write in symmetrical? Again, we apply the concept of ratio only. How ratio concept is applied here? We just take 6 as common from here. Isn't it? Therefore, x minus 1/3, 6, 3 and 2, their LCM is 6 only. Divide each ratio by 6. Divide each ratio by 6. So what do you get here? This is 1 and y plus 1/3. this is 2 and this will be z minus 2 by 3. Okay? So what is a point on the line is what? A point on the line is 1 by 3 minus 1 by 3, 2. And direction ratios of the line will be what? DRs are 1, 2 and 3. Direction ratios are 1, 2 and 3. Hope you have understood. There is no problem in it. So this way you can convert any line given in any form into symmetrical form. Next, 4 important point on the equation of line in symmetrical form. How to write equation of line parallel to number 1 x-axis, number 2 y-axis and number 3 z-axis, and passing through a given point. x1, y1, z1. How to write the equation of line parallel to x-axis passing through this, number 1 parallel to y-axis passing through this, parallel to z-axis and passing through. Let me do one, then we will be able to understand. The question is, if a line parallel to x-axis, I told you line can be written both in terms of direction ratio and direction cosines. That L y minus y1 by m, z minus z1 by line. This is the equation of a line A x1, y1, z1. What about element? Element are direction cosines. Already I told you line can be expressed in terms of direction ratios or direction cosines. I got direction cosines here. Why? Because if you want to write for number 1 direction cosines of x-axis are what? Cos 0, you know it, cos 90 and cos 90. X-axis make 90 degree with y-axis and then with z-axis. So those are cos 0, cos 90 and cos 90, that is 1, 0, 0. So equation of a line which is parallel to x-axis must have direction cosines like this. And it passing through x1, y1, z1. So how to write the required equation here? Answer will be what? X minus x1 by 1, y minus y1, point is given 0, z minus z1 by 0. Clear? Parallel to x-axis you got. Parallel to x-axis line you got. Parallel to y-axis. Second part how to write? Direction cosines of y-axis what? 0, 1, 0. So it will be x minus x1 by 0, y minus y1 by 1 and z minus z1 that divided by 0. Okay. Similarly, the third one, it will be x minus x1 by 0, z-axis has direction cosines 0, 0, 1, y minus y1 by 0, z minus z1 by 1. Okay. So I hope you got the basic idea of equation of line in 3D and few important points regarding the line in 3D. You can start solving problems from any textbook you have, NCERT or whatever book. You can start now. If the idea is clear, I hope you'll be able to proceed. If anybody has any problem, please send me your doubt. Write in the comment box or contact with me personally. I'll solve it. Okay? Thank you. See you again.